For as long as we've looked up at the stars, we've wondered what it would be like to go beyond them. To see the universe not as distant points of light, but as places, real, reachable, waiting. And somewhere along the way, humanity came up with the ultimate question. What if we could travel faster than light? It sounds like pure science fiction, and that's because, well, it is. At least for now. But let's pretend for a moment that it isn't. Let's imagine you could board a ship that breaks the universe's ultimate speed limit, 299,792,458 meters per second, the speed of light. Buckle up, because once you cross that line, physics itself starts acting weird. The speed limit of the universe. According to Einstein's theory of relativity, nothing, absolutely nothing, can move faster than light in a vacuum. Light is the cosmic speed limit, the universe's no trespassing sign. Why? Because the faster you go, the heavier you get. Not from too much pizza, but literally heavier. As you accelerate, your mass increases, and the energy required to keep going climbs exponentially. At light speed, you'd need infinite energy, and unless you've got a black hole-sized battery, that's not happening. So, in our universe, faster-than-light travel is impossible. But hey, this is a thought experiment, and humans are experts at ignoring the impossible. Breaking the barrier. Let's say we figured it out anyway. Maybe we've built an engine that doesn't move through space, but bends space itself, like folding a piece of paper so 2 points touch. This is the idea behind the Alcubierre Drive, a concept proposed by physicist Miguel Alcubierre. It works like this. You create a warp bubble that compresses space in front of your ship and expands it behind. You're not technically moving faster than light. Space is. Cool idea, right? Except there's a tiny issue. It might require more energy than exists in the entire observable universe. So, until someone invents an infinity energy generator, we're stuck here, paying our regular electricity bills. The moment you go faster than light, now imagine, just for fun, that you press the big red button marked FTL. The stars stretch, space warps, and suddenly, time starts getting weird. At near light speed, time slows down for you relative to everything else. At light speed, it would freeze completely. And if you somehow exceed it, time might start running backward. Yes, theoretically, you could leave Earth today and arrive somewhere yesterday. Congratulations, you just broke reality. It sounds exciting until you realize you might also arrive before you were born. Good luck explaining that one to your parents. Causality breaks down. When you go faster than light, cause and effect stop playing by the rules. You could drop a cup and see it shatter before you let go. You could send a message to someone in the past, maybe even to yourself. This is what physicists call a causality violation, and it makes the universe very uncomfortable. If cause and effect collapse, logic itself stops working. History turns into spaghetti. That's probably why nature doesn't allow FTL. The universe likes order. And if we start sending emails to yesterday, things would get messy fast. The twin paradox on steroids. Let's revisit the famous twin paradox. If one twin stays on Earth and the other travels near light speed, the traveler will age more slowly. When they return, they're younger. But if they travel faster than light, they might come back before they even left, which means they never went, which means they couldn't come back, which means they did, which means, yeah, physics just threw in the towel. At this point, Einstein would probably say, "I'm out," and go play the violin instead. The radiation problem. Even if you could go faster than light, you'd still have to deal with the universe trying to kill you. As you approach light speed, the particles in front of you compress into intense radiation, deadly, invisible bullets of energy. Travel faster than light, and you'd create shockwaves of pure energy. Imagine a sonic boom, but cosmic, a photon boom that could vaporize anything in its path. So yeah, congratulations. You didn't just invent FTL, you accidentally made the world's most dangerous space toaster. The shortcut idea. But maybe we don't need to outrun light. Maybe we just need a shortcut. That's where wormholes come in. Tunnels through space-time that could connect two distant points instantly. Sound perfect. Step in one side, pop out light years away. No need to break the rules. Just cheat them. The catch? Wormholes are unstable. They collapse faster than you can say Einstein-Rosen bridge. And keeping one open might require something called negative energy, which we've never actually seen, but hey, details. So yes, the universe has shortcuts, but right now, all of them are marked under construction. Why are we so obsessed with breaking the speed of light? Maybe it's not about speed. Maybe it's about defiance. Every generation of humans has looked at a limit and said, we'll go further. We did it with flight. We did it with space travel. And someday, maybe, we'll do it with light. Faster than light travel represents something deeper than science. It's the idea that curiosity can outrun everything, even the boundaries written into the universe itself. Until that day comes, the speed of light remains undefeated. But maybe that's not a bad thing. Maybe the beauty of space isn't in conquering it, but in knowing it still holds mysteries. Because when we look up at the night sky, we're not just seeing stars, we're seeing the past. Every beam of starlight is a story millions of years old, traveling all this way so that we could witness it. We can't go faster than that light, but we can chase it. Because that's what humans do. We imagine, we explore, and we keep asking, what if? Even when the answer is impossible. And who knows? Maybe one day someone will press that red button and the universe will whisper back, finally. If you enjoyed this journey through the edge of science and imagination, don't forget to like, share, and subscribe to Wiseuse, where every question opens a new universe of ideas. After all, curiosity might not be faster than light, but it definitely travels farther.